Hi everybody, it's Greg, and today I want to talk about using power sources in parallel or in series. It's a simple thing, maybe so simple that it's kind of confusing sometimes. It's one or the other, so which one is it? Okay, let's talk about using two batteries. So I'm going to put these two batteries right here. And this is a commercial for Rayovac. No, not really. Okay, so obviously this is the positive tip and the negative tip. And it's lined up here also. This is the negative tip and positive tip here. So when I put them together, it's going negative to positive. And so this end is still positive and this end is still negative. And I put them together. This is just like you do in most of your flashlights, like this flashlight right here. If I undo this and look at these batteries that are in this flashlight, this is exactly the way they are put in the flashlight. Positive to negative, and it's just two batteries in a row that slide right up into this tube. That is what's known as two batteries placed together in series. Okay? And you see, your AA battery is going to have about 1.5 volts all by itself. When you put two of them together in series like this, it's going to add up the voltages. So 1.5 plus 1.5 will equal now 3 volts. And that's how many volts are now going to go into this flashlight, as you can see. So, and you know, this LED is designed to take 3 volts for optimum usage. Okay, now what is using batteries in parallel? Imagine that they're lined up this way, and you've got some sort of device where, in effect, it's like you've wired all the negative ends together, and then you'd have like one wire that connects to all of those negative ends and comes off here, and that's your one negative wire. And then imagine you've got a wire that connects to all these positive ends and goes off here, and that is your positive wire. What that would do, in effect, is they would still be 1.5 volts. It does not add up the voltage, but it does add up the milliamps of the batteries, or kind of the grunt, if you will. So what would be a time when you would have them in parallel like this? Well, I suppose, I don't know that much about big diesel trucks or whatever. Maybe you've got more than one battery in your big diesel truck, and it's all a 12 volt system. So you got a couple batteries and you've wired them together in parallel. So you've got the negatives together going to the negative terminal, the positives together. So that's going to still give you the same 12 volts of your automotive battery, but it's going to give you more grunt, more cranking power for something like a diesel engine. There are also some electronic devices you might use, portable devices, where in effect the batteries are placed in parallel instead of in series. Oops. And I'll give you a great example right now, something, let me just show you. Here are two kinds of battery adapters that you might use. This would allow you to put AA batteries in place of D batteries in certain devices. Here's one that you can use two AA batteries and place them in here where you would normally use a D battery. So in this case, I'm going to put them both in positive side down. So they're both positive side down, negative side up. Then I close this container, and there you go. That is a parallel application of two AA batteries. Together they're still going to give the same 1.5 volts that they normally give, but now that's going to add a little bit more grunt, making them a more suitable replacement for a D battery. So that's in parallel. And here's one that actually you can stick, you could stick one AA battery in there if you only wanted one, or you could stick two if you wanted to use two. Now you can put 3 AA batteries in there. And again, still 1.5 volts, which is the same as a D battery, same as a regular AA battery, but altogether it gives you more milliamps, more grunt for your replacement of a D battery with a AA. Now here's a flashlight I have. This is kind of nice. It's kind of a blacklight effect on LEDs. Don't look at it. Okay, this one has a very interesting battery compartment here. Okay, don't get these mixed up, because this one that came out of the flashlight, these 3 AA batteries are in here in series. So instead of them all being positive side up and negative side down, there's one of them that's turned the opposite orientation. And I put little arrows on there myself just so I knew the correct way to slide it back down into the flashlight. So what this does is, this is in effect, it's like taking these 3 batteries and lining them all up in a row, but instead you've kind of folded them over, and the little electrical contacts inside allow them to go from, you know, this one negative, positive, linking over to here, positive to negative, kind of making this jump here and going across here, and then coming across here. And so, and then the right ones are going to this end and this end. And so what this is doing is, in a series configuration, it's going to increase the voltage to 3 times what any one of these batteries was by itself. And that is the correct voltage for this particular flashlight, more like 4.5 volts or slightly higher, because the alkaline batteries tend to give you just a little bit more than 1.5 volts. And well, let me just show you. So now, just to prove to you that this is working the way I said it's supposed to work, I have a little battery tester here. So I'm going to stick one of these AA batteries in here and show you that it's 1.6 volts. Okay, so close enough. And here's the second one on this battery tester. Okay, 1.55. And then here's the next one, and it's also about, you know, okay, 1.57, thereabouts. I stick them in this battery adapter where they're all going to be in parallel. And remember, that's not going to increase the voltage. It's still showing 1.57 volts between the 3 of them, but it's going to have more grunt because of the way they're all wired in parallel there. But now let's just quickly check what happens with our other, this adapter that puts them in series. And I'm just going to, for the sake of being thorough here, I'm going to place the same 3 batteries that we tested into this other adapter. Okay. Where two of them go in this way, and the other one is the opposite orientation, so that the 3 of them together on my little tester here are testing out at 5.13 volts. So since they weren't exactly 1.5 volts, they were each a little bit higher than that. Instead of this coming out to exactly 4.5 volts, it's a little bit higher than that, but still within the parameters needed for this flashlight. So there you go, a simple, okay, if you are on the internet looking for a battery adapter like this that you want to use for using AA batteries in place of a D battery, make sure you get one that says they are in parallel. Okay, but if you want to increase the voltage, then you can get one that says they are in series. That's right. So, and again, this one is it's the only one I have that's in series because it's specifically for this flashlight, which is the only one I have. And then I got a bunch of these because I wanted to adapt AA batteries to use in place of D. So again, the concept, series versus parallel. Now you're ready for the quiz. I don't have a quiz. However, it's a life quiz, okay? So if you get the wrong adapter, like you get this, and you try to use it where this belongs, that's your life test, and I'm not going to be there to grade you on it. You're probably going to fry something if you get it wrong. So parallel versus series, have fun with that one, kids.